All right, welcome to the July 27th AnonCreds Working Group meeting. We'll see how much we have to discuss today in AnonCredsBBS. An announcement that we're splitting the V1 JavaScript wrapper out of the V1 implementation, and talk to Victor a bit about where he is with the Revocation Manager. We are recording, and this is a Linux Foundation Decentralized Trust Meeting. So the antitrust policy of the Linux Foundation is in effect, as is the code of conduct of LFDT. Any announcements or anything else to make? Anything else people want to talk about? Okay. PR 42, where are we on that? Mark, are you happy with this, that we can merge it?
I put a bunch of review comments and we discussed some requests. I haven't seen any response to any of that, so
So
not
hold
really.
off.
No.
Mike, are
I
you
would
able,
rather do it in a follow-up PR. I
you
don't
want
have
to do it in
time
a
to break
follow-up?
things apart. I don't have time to break things apart and do all of this stuff right now. So
So,
I'm
Mark,
happy to
would you
do a
be okay
follow-up
with,
next week because I don't have any time this week.
do you think should we merge this one and then you do the follow-up on the next? That's
Yes,
that's what you would prefer, Mark? Are
that's
you
what I
okay
would
with that?
prefer. And put these as issues, and then I can close them out so that they're not forgotten.
Mark,
That
is that
would
okay with you?
That is not my preference. By the way, Mike, you said in the comments that you didn't intend to split them apart. So I said, okay, then please just make clear what's in here because there's changes to the signature scheme that aren't signaled at all in the commit comments or PR description. I think, yeah, ideally it would be split out. I understand now that the signature scheme change would come first and then the equality enforcement would come second. Um, I I would think it would be better if you are going to split them. I think it would be better to just do that. I'm sitting on my hands because I could try to split it myself and offer that as a contribution, but I just maybe I'd run into trouble and kick myself that I had done that. But if you want to merge it now, I mean, the point of separating it is to not merge it together in one thing, right? So if you merge it together in one thing, you already have. And if that's going to be the case, I would just suggest, again, as I did in the pull request, to uh, signal that explicitly, because these are two, yes, they're related, but they're in another sense quite unrelated changes that, for example, the signature scheme change is a breaking change. In other words, someone who's got a credential from before this will not be able to verify it afterwards, whereas the enforcing equalities is not a breaking change, right?
I doubt anyone's used the other BBS
Yeah,
because
I
it
mean, they definitely wouldn't have used the BBS. It's been alive for a week, 2 weeks.
Right. Okay. Well, you don't officially require my approval. I've just got my polite request that ideally these are separated, and if not, then both are clearly signaled in the PR.
Okay, so this is one part, and you're saying as well there's updates to the signature scheme, and that's what you want in here.
Yeah, he just wants another documentation comment. That's easy to change. I can do that. Some of the comments on the code, like it was given how little time I had, like not that I was trying to copy and paste and write crappy code. It was just the Rust compiler doesn't make it easy to abstract some of these. And so I didn't want to do too much in one PR of refactoring and cleaning things up. So
Right. I think most of my comments are relatively minor, right?
Well, there's a few that you've said this is duplicated here, and that's
Oh
why I
yeah,
said I'm
yeah,
happy to do a follow-up with that because then it makes the PR even bigger. It's not quite
right.
as straightforward as it may
I
seem.
get you. Yeah. I get you. Yeah, that's all part of the process, isn't it? There are a little couple of places where the sizes that are allocated for something, I believe, that should be changed because the signature scheme changed, and it would make sense to fix those. Um,
Sizes for maybe I haven't read all your comments recently.
yeah, there's a couple of places where, let me see. Just the capacity of some vectors is out of date because there's more things covered by the different signature scheme. There's the last two commit comments.
Right
Oh,
there.
sorry, yeah, PR comments.
Yeah, right there. This should be +3. This should be +2.
Yeah.
Yeah. Yeah, I thought those were pretty sounded serious.
Well, it's just
They're not. It's just
could be addressed.
pre-allocation. Rust will
Yeah.
just allocate the right thing anyway.
Okay. Okay.
So it's not a huge thing. Like if the only time you'd really even notice it is if you're like calling this a bazillion times a second and it has to keep allocating over and over and over again. So you would definitely notice it then.
Yeah.
But like I said, those are minor. Those things I
Yeah.
can't change. Those,
Okay,
those,
so the idea,
those are decent.
Mike, is you're going to do a quick pass, do a quick couple of quick updates, reframe the title and the first comment, and then assuming that goes well, we'll merge.
Yeah, that's fine.
And you can do that, say, if we end this meeting a little early.
Probably.
Okay. Um, okay.
The big thing
Any other
that's
comments on this?
well, the big thing that's tough is the ePrint paper on BBS. So let me get
Yeah,
this in this meeting so it's also recorded for future
yeah,
notes.
yeah,
If you look at the ePrint, they say, oh, you can just do this and it simplifies things and shrinks things. Okay, great. The problem with their suggestion is it breaks predicate proofs.
yeah.
And so that was one of the issues I discovered in this PR. So that's why I also fixed it here. But at the same time, it was the linking of the proofs that was the other bug. And so I most like the other BBS signature would never have worked with predicates.
Right.
It will in this one, but I also fixed the other issue. So
Okay.
the IETF draft does work with predicate proofs because it was before the ePrint came out. So according to the ePrint, that's or not the ePrint, the IETF or IRTF, that's what's in the code here.
Okay.
Right. So one of my other comments is when you say the ePrint and the IETF, people less familiar with it, which includes me, don't really know what document you're talking about, so can't go and check those details if they want to. So I wanted to see those, and also the README comments are out of date, so that could be updated as well.
Yeah. Can you put in the do you have them handy, Mike, that you can put in chat?
Yeah, I have the markdown. Let's see. Here's the IETF.
Yeah.
Let me find the ePrint. Where'd it go?
And you just said the ePrint was later than the IETF, but I think
Yep.
it's the other way around, right?
No, because they didn't incorporate anything from the ePrint into IETF. So they either rejected it or they ignored it.
Because the IETF was all done in the last 2 years.
Well, the ePrint just came out last year. Well,
Oh,
2023.
okay. I thought the ePrint was from much earlier than that. Okay, which again is
No.
why we need the ePrint link.
Oh, found it. Here it is. Okay. Yeah, it's 2023.
Ah, okay. Okay. I thought this was the paper that
I'm on page 9, by the way.
that removed the need for the plus on BBS plus, but wasn't that 2016?
No, it came okay. So the one that came out in 2016 added the BBS plus. Added
Oh, okay. And
that's
this
the
one
one by
removed it.
Kamenish and others. That
Yeah.
one's the one that was originally implemented from IETF. Then in like 2021 or 22, I'm trying to remember which year, some comments came out that said, oh, we just redid the security proofs for BBS, and it turns out we really don't need this specific parameter. And I think they came out in crypto 2022, something like that.
Okay.
And so then the IETF draft adapted to that one. And then they said, okay, we're done. And then they've been sitting there. And then this one, revisiting BBS signatures, came out. So,
Okay. But this one drops but
well,
but the change they made loses
yeah. So
what
if
you're
you
using for
really want to see where it happens, if you can click PDF, let me find the page number. Let's see if I can find it. Okay, no, not signed. That's all. It's in the proofs. I'm trying to find it. Just a second. They have this concept of what's called signature randomizers, and they have to multiply every message by that randomizer, including the signature, for it to verify. But the problem with that is that's what breaks the ability to use it with predicates. Why am I not finding it here? Most of these are like just security proofs. I'm trying to find the actual one that it was. Okay, I think it's in section 9. No, 5.1, I think is where it is.
It's where I am.
Yeah, hang on. Yeah, here it is. So it's on page 24. You'll see there's an equation at the top where they say, given this signature, pick a random R, compute it over like everything. And you'll see it includes the messages on that first equation.
Right.
And that's what breaks it. That's what breaks the predicates. Because as soon as you modify the messages, you can't link it to anything else. So it throws off everything. So like, for example, say one of the M's was your age. You would have to now know this signature randomizer for both proving and verifying. That's why it wouldn't work.
Yeah.
So anyway.
Okay. Okay, I'll add those to the notes and make sure, maybe I'll try to do an upgrade to the README. So now the ETF draft is the one that is primary.
Yep.
And yeah, okay. Interesting. Okay. Oops, that's not the one I wanted to be on. That's not the one. Where am I? There oh, I know why. Sorry about that. Nope.
Basically, by using these references of ePrint and IETF, I just hoped that Mark would be able to read my mind.
I tried to read it. I couldn't understand it.
I still can't, or I can't even read my own mind, so I don't know what's going on.
Okay.
All right, so I'll make those small changes, and then I'm happy to do a follow-up. Before we merge it, I'll create the issues so that when I do a follow-up, I can say this PR addresses the following issues. That should help keep the cognitive load of the PR lower.
Yeah.
Follow-up. But this is just BBS, not BBS plus.
Yeah.
So
Okay. Just an announcement, doesn't really, it's not that relevant since all of us here are mostly working on V2, but anyway, split of AnonCreds RS V1. I should specify into 2 repositories, the Rust code with the Python wrapper, and then a separate AnonCreds JavaScript wrapper. We did this in Ascar, which has the same Rust and wrappers architecture, and it turned out to be an improvement. So we're going to do the same with AnonCreds. This repo was just created today. So, whoops, not Ascar and not in OpenWA. Sorry. Let me try. And so oh, sorry about that. So basically a bunch of work is going to go on to remove everything that looks like the Rust implementation and the Python implementation out of this new repo, and everything that is the JavaScript wrapper out of the initial repo, and they'll each produce their own artifacts appropriately. Finally, we get to Victor.
Just a quick question on that. So there's no functional change or licensing change or anything like that. It's just splitting repos for kind of administrative purposes.
Yeah, it's for separation of. We had a big problem with Ascar in particular trying to get Android working. It just wasn't working, and we had people that know Rust in one repo and people that know JavaScript in the other, and they couldn't figure out how to get a release out. So we decided to separate them out, get the Rust release out using just Rust tools, and then figure out the JavaScript and including the React Native / Android stuff separately. And that worked out rather well with Ascar, much better than we thought it would. So, Victor, are you progressing?
Yeah. I finished 2 of the issues I was facing last week. So I fixed the code bytes, and then I also fixed byte buffer in the Python end. But I'm still facing the issue with hashing. So even modding the number Mike proposed last week, I'm still not getting the same hash values between Rust and Python.
Okay, I will have a little more time on Thursday. I can take a look.
Yeah, I have this test script that's under. I'll just can I share my screen?
Yeah.
Okay, I can share it now. So I have this test script that basically mods this value you mentioned yesterday. You mentioned last week, and this is also being mentioned in the implementation of scalar. So scalar. Like this is the value that's mentioned here. And I'm still not getting the same scalar values between Rust and Python.
The other issue you could possibly look at is little versus big Indian. That always makes it fun. The reason I say that is the Rust might be interpreting the output of the hash as a little Indian sorted big integer, and you're interpreting it the other way. So
would fixing this work?
Well, you can use that might work. I don't know. Usually I just reverse the bytes. So
Oh, okay. No. Not really. Not really. No, it does not. I'll look into that, I guess.
Yeah, give it a shot.
Yeah, you mentioned converting from Rust. So I'm not that familiar with hashing. Do you mean reverse the bytes? Like, what do you mean by reversing? Like converting from big to little?
Yeah, I mean that's literally all the difference is the order of the bytes. So when you there's this concept in cryptography, especially in elliptic curves, where you hash to a group element. Well,
Mm-hmm.
elliptic curves have two. There's the group that the points operate on, and then there's the group that the scalars operate on.
Mm-hmm.
And so usually the best way to do it is you hash to generate an output that's twice the size in bytes as the group order, and then you reduce by the group order. In this case, the scalar is modulus. That way, one, it's evenly distributed and avoids bias, but two, it's a nice random number that nobody could have predicted. So,
Mm-hmm. How's that have to do with little and big?
because when you're hashing, typically you'll say, oh, I'll use shake or I'll use SHA-512 or whatever, and that has an output. Okay. So that output, when it's interpreted as big or little Indian, like the Rust code, I think is taking it as little Indian, saying byte zero, index zero is the least significant bit, and if you're doing big Indian, then the byte at index zero is the most significant byte.
Oh, I see.
So if you're interpreting left to right versus right to left, and
Yeah,
so when you reduce, you're going to get completely different answers.
I see.
You sound sad about it.
This is confusing. I might need to ask GPT about that.
Well, all you do is reverse the order of the bytes to get between the two. That's literally all you do.
You're talking about this, right?
I don't know exactly what you're doing. I'll have to take a look. But
Okay.
yeah, if those are the bytes, or you're saying int from bytes, so you reverse the hash bytes,
I see.
not the number. By then it's too late.
Revert. Yeah, I see what you mean. I just had a comment. I don't think they're, yeah. Okay, just,
Revert or reverse?
Reverse, not revert.
but I
Revert
don't
what?
think bytes have reverse functions.
Yeah, I think well, lists definitely do. So I don't know what I I have not programmed in Python in a long time.
That's okay.
It's hard to program in an inferior language. Sorry, Stephen. I know you guys love Python.
That's not me.
Oh, I do machine learning, so yeah.
To me, Python's a good intro language and it's good for many things. It's just not that great when you're
Okay.
doing systems level or cryptography.
This.
So, again, personal preference.
Will this work?
I'm dying to find out if this works.
No. How about this?
Now you got four things to change.
Yeah, no, it doesn't work.
So, I think you're probably using Shake and I'm not. I don't remember exactly.
That would be a big difference.
Shake 1 to 8.
And what are you using?
I'm using the same shake. I'll use shake 2. Like
No.
like like you didn't mention shake in the
No. So, hang on, right here.
uh-huh. Like you use shake 1 to 8.
Mm-hmm. And are you passing in the same salt?
Yep. The salt is the same. It's a global variable. I don't think I'll be able to find it.
Sure you can.
Yep, this is the
There.
same. So
It's the byte representation of that string.
yeah.
So as long as it's the same, you should be okay. So here you're saying, hang on, what is this? Okay, assuming IKM is none, you're generating a random 32 bytes and up. Wait,
Yeah,
what?
but I'm passing the IKM as one here. Wait,
Oh, okay, I see what you're saying. All right.
this is just a placeholder, like just in case.
No, I get it. So, all right. Well, I just noticed you're reversing the bytes and then you're saying read this in byte little byte Indian order on the next line. So which
Oh,
Yeah, but
effectively
he tried
undoes
big
it.
as well. He tried big as well, but
Nothing works.
no. So this is Rust bytes, but then it's not even close.
well, it's either going to be right or not right.
Yeah,
Close isn't close
There's
is
no such
irrelevant.
thing as close. It's always
Exactly.
it's equal or not equal.
right.
I wonder if I can figure this out here. Give me a second. What's the module for shake? Is it I always forget what it is. What's the module that uses shake?
I have no idea.
Aren't you importing it from
You're using
somewhere?
it. You're using it. You
This
should.
one?
No, when you say import.
Yeah,
Oh,
where's your import?
no, I
Yeah,
have
okay,
no
hash lib. Okay, yeah.
one to eight. Did it tell you?
Why is it not working for me? Do I not have it installed? Okay, there we go. All right. I always forget where it is. What's the repo link? Can you send me the link?
Yeah.
Or even paste it here in the chat. I
Yeah,
don't
it's
care.
in the chat.
All right, there we go.
So there's this test folder that's under Windows Server.
All right, so if I go to utilities, there's generate FR. Okay. Okay. All right, let me look at where that hard-coded salt is. What was the name of the file it was in? I
ACC.
think it's key.rs. I found it.
What?
Oh wait, no, that's keygen.
It's in utils line 57.
All right. Is that how you do it in Python?
B, yeah, this is how you convert to bytes, right?
Well, I don't
I thought
know.
that's the same thing.
I haven't used Python in years, so.
Oh, this is pretty funny.
Yeah, Python does the same thing.
All right. Is it double quote or single quote? I guess it doesn't matter. Okay.
In Python, it doesn't matter.
All right. That's the first ding I have against Python. Doesn't matter. All right. So if I say, is it update? How do I? Yeah. And then you just did the one,
Yeah, B1.
B1. When you tell it what you want. Oh, didn't like that. Oh. Okay. Let's see here. No, that's not what I wanted.
Oh, you still have
Oh, B. Okay. Okay. I'm just trying something. And you said you did from bytes.
What? So this comes from the from bytes. Let me try to find.
Say, I need to drop off. Can I? But I
Yep,
do have one question before I drop
oh,
off.
fire.
Uh, on the website, I mean, on the page of AnonCreds R2 V2, I think it says the code, or at least I've heard in this meeting that some of the code has been audited. Uh, what code has been audited?
Mike has that list. I'll try to get it from Mike if
The
you.
the blissful dependency has been audited. So if you go in the cargo.toml, one of the dependencies BLS full, I call it blissful for short, that one's been audited.
Oh, okay. So it's not the V2 RS code that's been audited. It is some of the dependencies.
Some
Yeah,
of the dependencies have been audited, yes.
yes.
Okay, great. Thank you.
It's a great place to start. Start at the bottom and work your way up.
Yeah, I agree with that. All right. Hey, thanks. Gotta go.
Take care. See ya.
All right. Let
This
me.
is just entertaining. So what do we got now?
The bytes just come from this. Like hash.
Well, that's what you're trying to do.
Yeah, this is how I got this value in Rust.
Okay, just a second.
Be pretty funny if it's your Rust value that's not right.
It might be. I'm just firing things up. So I got what I think you got in Python.
Okay.
So let's see.
Let me just.
Um, hmm. Oh, there it is. All right. All right. I'm trying to print what I got in Python. And then I got that. And then what I got in Rust. And yeah, they're not the same. Oh, duh. It would help if I hashed the same value.
That definitely would be
Okay,
helpful.
I got it. I got Python and Rust to work.
Oh, good. Let's see what you got. Time for
Hey, here, I'll
Mike
show
to
you.
share.
Here, I'll share my screen.
Okay.
So here's Rust. See, I just had it print. There's your 2.
Yeah, this is
And
the
here's
same
my
one.
and then here's my Python code. So I said hash the digest, read it from little Indian mod Q, same value.
Huh. Hold on.
Interesting.
You got little int from. We have the exact same code, don't we?
Are you doing mod percent Q?
Yeah, percent Q. Wait. Yeah, I'm doing percent Q.
So here's what I did. See,
Shaker update
there's the salt.
0x. Oh, hold on. Let me try this. 0x 1. Let's see.
Well, I did this, and then I said hash bytes. Give me the hash bytes.
The
Or
salt we
this
have.
one, and then I said, okay, there's my Q. Try big Indian mod Q. I got this. Try little Indian mod Q. Got that.
What?
Same value.
We have the exact same code. Oh no.
My guess is you're probably not refreshing it or something. Like,
Can I see your code again? Can I take a screenshot and paste it in the chat?
I'll just paste the code I have in the chat.
Yeah, that'd be nice. Did you reverse the bytes?
Nope, didn't reverse it. All I did was say little, and it worked. Why can I not chat? Oh, there we go.
This is killing me.
Line 1, line 2.
No, I'm not getting the same answer.
Line 3.
Why you update 0x01?
Oh, you're doing Shaker Digest and he's doing Shaker Update.
No, like you have 2 lines, so update 0x01 and then
No,
That's the
failed.
value you're hashing, right?
no,
So
but
look, it failed right here. When I try to just do a raw byte, it goes, you can't do that.
Oh, I see. Oh, okay, Shaker Update. But
what's shaker?
Victor, you're doing Shaker Digest.
I don't have shaker. What's shaker?
Shaker's right here. I just created a new.
Oh, shaker is called. Yeah, your shaker is my shake.
Yep.
Oh, I see. Oh, Shaker versus Shake. But anyway, you're doing Digest, whereas Mike's doing Update. I don't know what that difference
I'm
that
doing
means.
the same thing. I'm doing this.
Oh no, then he's got, sorry, you're right. Then he's got Shake Digest 64.
That's literally all the lines I just did. 1,
So
2,
that
3, 4, 5,
I
6,
don't
7,
understand.
8,
What?
9.
What?
so Mike, copy what you just put in chat and rerun it just to make sure you got them all.
Okay, let me try one more time.
Okay, watch. Let's see. How do I? Oh yeah. Okay. Python 3. Oh gosh.
Never mind.
Let's see. No. Warp. Okay, good. All right. One more time. Where's my chat? Okay, there we go. This is literally what I got. Okay. So if I just copy the same lines I sent you, I'll probably get the same answer.
Big int.
Make sure you're also on the same version as Python, which is just Python 3. If you're
Oh,
on
yeah,
Python
same
2,
answer
that
as you, but my function doesn't give me the same answer. Yeah, I can replicate your answer. Yeah, no, you don't have to do that. I already got it. Why this is not working?
My guess is your code is probably not refreshing or something like that. You might be an older thing. Yep, see, same answer.
Yeah. What?
So yeah, it's just like I said, it's coming in little Indian. It's interpreting as a little Indian versus big. It's the only thing that's wrong.
Oh, let me see.
So
Let's see yours. Come on, Victor, show it.
my guess is something's off in terms of like it might be using an old binary or something, unless he's got it to refresh every single
Oh,
time.
I can replicate your answers, but without a function. But
But hold on.
Then the only thing that would be different is what is the IKM you're passing in? Can you print it? No. Now you just did it.
Yeah.
Okay.
You put generate #1 at the bottom, which makes this an infinite loop. Don't do that.
Oh yeah. Sorry. None. Oh, this is the reason. Crap. I know. How about this? Um,
I was gonna say, is generate hash the first argument? You're replacing the salt,
Yep. Replacing the
or
salt.
do you need to say v equals b double quote 1 when you call it down below?
Oh. Yeah.
I think it's replacing the salt, and that's why you're not getting the same answer.
Well, yeah, I see. Okay, my fault. Yeah, I'll change it back to IKM. And then this. Yeah, this gives me the same
There you
answer.
go. So yeah, you were.
Well,
That's
that
why
was
you're
fine.
passing in and replacing the salt, and ICAM was always empty.
Yeah, makes sense. My fault.
Oh, there you go.
Excellent.
We fixed it.
Yeah, that fixes everything, I think.
Good. Well, that
Uh,
was entertaining. I enjoyed myself.
And it's all recorded, so you can listen to it over and over again every night.
Exactly.
Laugh yourself to sleep.
yeah.
All right. Anything more to talk about today?
What else do you want? Where do you want AnonCreds 2.0 to go from here? Now that we've got BBS in there, is it time to make it easier to use, like with some builder patterns, or wrappers of other languages? What's the next step?
I'd go back to the to-do list.
Okay.
Let me,
Well, think
I
about
would
it.
think,
If I can throw in something that we've talked
Yeah.
about before, the decryption of verifiable decryption and the verification of decryption.
You want it actually to work. Okay.
Ideally.
Ideally, yeah. All right.
yeah, I agree. Oh, Mike, I have a question for you. Or Mark, one of the, you guys will know this. So if I have a credential that has a host, or sorry, an issuer inserted value, and I use that as a synonymous, as the source of a synonymous identifier. Okay.
The link speaker or
I want it's this situation where I want the verifier to get the same value back, but each verifier gets a different one. So a synonymous identifier.
the context proof or something. I can't domain proof. I can't remember what you
yes, domain proof.
Okay.
If I issue a new credential as an issuer to the same holder and using the same value, Will the new credential also produce the same value for a given verifier?
Yes.
Okay, that's what I thought. I just wanted to confirm that. So basically, I can put a unique identifier for an individual into a credential, and then every verifier, and I can reissue that over and over. So if they lose their wallet, they lose their credential, as long as they get the same value from the issuer each time they get a new credential, every verifier will get a consistent identifier.
Yes, they will.
Okay.
The biggest problem you have is knowing which one to compare against.
Meaning?
Well, if I have a domain proof that I register with like 10,000 users,
Yeah.
they don't know which of the 10,000 is theirs, do they? Unless they remember from the first time they did it. Because remember, these are like random values, right?
Right.
So
The
you
domain
need-
proof. So if the verifier gives the same domain value each time, and the holder is using the same value in the credential that they used last time, the result for the verifier is going to be assigned.
That's correct. As long as the verifier
Consistent.
knows which one to pick.
Yes. So what we're thinking of is something like you have a person credential coming from a from a known source, like I don't know, a government. And so you have the government does the identity proofing of the individual, and so they've got a consistent identifier for that individual. They then put that consistent identifier into the verifiable credential that the holder has, but the holder only shares it as a domain proof, as a synonymous identifier. They never share it in plain text.
Yeah, like I said, there's two different ways we can do it, and I thought of, but both of them achieve the same thing. So one requires updating verifiable encryption, the other is just using commitments.
Okay.
The verifiable encryption one's probably better. Just because of the proof will be quicker. But the other one works too.
Okay. Okay, I just wanted to make sure of that because we're talking about that a whole bunch right now, and we're just trying to figure out.
Yep.
So the idea goes, you want to get government services, you want to have a single identifier associated with the resident, but you don't want to, for all the verifiers, to get that unique identifier. You want each service, even though it's all government, you want each service to get a different identifier, so there's no correlation across.
Correct. The only thing you would
And-
know is this a repeat customer versus
Exactly. And you want to know it's a repeat customer, and you want to know which one, and you want that to work even if the person's wallet goes away.
Yes.
Okay, that's what I thought. Good.
I just want to, I think we've talked about this before, Stephen, that to tease this out in a couple of dimensions, right? One is saying it's the same for each verifier. It doesn't need to be that right way, right? Like I could use a service and have different identity, different
Yes.
pseudonymous identifiers for that same service. Or
Correct.
use the same one for multiple services, right? So
Correct.
making it one-to-one with verifiers is like confusing. The other
Yeah,
thing is
okay.
about the verifiable encryption might or might not be used, with the same attribute. I hadn't thought before about using it with the same attribute, so that seems like it would require a little more magic, the kind of which Mike invents. So,
Well,
sounds
the
quite
thing is, if you don't use the same one, then they don't know if you're a repeat customer, right?
Well, they can. We can use two different attributes, right? One is for my pseudonymous identifier, and then another one might be a single, identifying piece of information like a social security number or something that can
Right.
be decrypted by an authority, the authority might have no interest at all in this pseudonymous identifier, right? They just want to know who the individual is.
Exactly. Yeah. So the one is a verifiable encryption as is for auditing, where you want to get the number back from the verifier and figure out who it actually is. And the other one is for that consistent identifier across all domain strings. Now, what, Mike, is what you're saying is it's possible to use the same attribute for both of those? So in other words, I could encrypt something consistently so that you get the same encrypted value and then present that. Okay, interesting. All right.
Yeah, so what I'm thinking is you do a verifiable encryption of the value you want.
Mm-hmm.
Now, here's the thing. There's two different ways you can do verifiable encryption. One where you decrypt to the actual scalar value,
Yeah.
or one where you decrypt to kind of like a public key.
Yeah.
The decryption of the public key is the one I'm talking about, and that's currently what's supported in AnonCreds v2. What Mark is wanting is the one that decrypts to scalars.
Mm-hmm. Yeah.
Right, Mark?
I'm not sure what you're saying is currently supported. I'm not aware of any decryption that works.
No, the current one does, it'll decrypt to a public key, basically, is what it does.
All right, will you show me that? Like, send me a link to a line of code so I can explore that, because when I've looked for it, I've not found any decryption.
Well, it's just El Gamal, so all you have to do is, as soon as you know what the public key is, which you did during proof generation, you can decrypt it to the public key, which essentially is just a commitment to the value that was. So
who's public key?
Well, so the values that are signed, think of them as like private keys, right? You don't want to reveal these unless you absolutely have to.
The particular attribute that we're using to identify the person in case they misbehave, that one.
Yeah.
Right.
Yep. So what it does is the current verifiable encryption, what it will do is it's using El Gamal encryption. So you can prove that you committed the message that was signed by the issuer is also in the ciphertext. Now, when you decrypt it, what it does is it basically becomes from a Pedersen commitment to just a regular public key value. So a common term in cryptography is called it's still in the exponent. So you can't get it out. That's the current one that's in AnonCreds v2. So
okay, you say when you decrypt, show me anywhere where something decrypts. That's what I can't find.
Okay.
Well, the flow test doesn't have it, right?
That's a very simple line change. It's literally just give me the public key no, you need the private key, not the public key to decrypt. Yeah, that one's
so there's a decryption key, but it's not used anywhere.
Yeah.
As far as
I'll add that. Is there an issue for that already? There might, if there's not, then I'll just create one. But that's the one that's currently in there. Now, if you want to be able to decrypt out of the exponent, that one's a little more intense, and I've done it before. In fact, there's public open source code at Lit that does it. So we can just use that too. We call it verifiable share encryption, but it's the same idea. That one allows you to decrypt out of the exponent. So that would actually reveal the actual secret value that was encrypted. So sometimes you want that and sometimes you don't.
Yeah, the use cases that I'm interested in, that I think about, you want to know what was that original scalar value. Yeah.
Yep. Okay. Well, that's an easy change.
Great. Happy to hear it. Easy for you.
I think in our use case, just so you know, in our use case, we wouldn't want to use verifiable encryption. So we wouldn't use an actual something like a social security number or something like that. We would want to use some generated value that's associated with the person, put that in the credential, and then have each domain proof, each domain string produce a different value.
Yeah. So
Okay.
that still works with verifiable encryption where you decrypt to a public commitment.
Yep, got it.
That's how you would do it. Because you would prove, okay, I encrypted the value, and then when you guys decrypt it, out comes the domain proof. And it would be the same every time.
Okay, got it. All right, I got to run. This is a good
No, you
meeting. That
don't.
was fun. Thanks,
No,
all.
you don't. It's late.
It certainly is from Victor.
Yeah, I'm gonna
All
have to.
right.
Well, we
See
figured
ya.
out his problem, so we're all
Yeah,
Yeah,
I'll
that
wrap
was
it up.
good.
Yeah,
Good.
okay. All right.
Thanks,
Bye.
everyone.
bye bye.
Bye.